seen. Matthew graduated just this term. Last term. So his graduation was just this Tuesday. And I had the pleasure working with Matthew and Hossein, Dr. Hossein Hosseini, also co-supervised Matthew on his honors research. And today, actually, Matthew will present the work that he has done in his honors research project. He did a really great job. I was going through his thesis and all of data collection, everything. I can vouch that Matthew actually did a really great job and very diligently actually worked on his research project. But before I hand it over to you, Matthew, can you also give a bit of, again, introduction, what you do now and what you learned, etc. So, and then you can also present your research.
Perfect. Thank you. Thank you, Ellie, for this. So hi, guys. My name is Matthew, and I first met Ellie at the end of 2022 when I was an undergraduate student in my second year. So as part of my undergraduate studies, I have participated in multiple extracurricular activities, a lot of which were case competitions, where case competitions is an event that's run by industry with a university club or university society, and they run these case competitions for undergraduate students or for students in general to have a taste of what industry is like, in particular the consulting industry. A lot of the case competitions that I've done were sustainability focused, so a lot of them I did case competitions in terms of waste management, circular economy. I did one on high-speed rail, and I also did one on net zero. And it was my last case competition I did was at the end of 2022, and it was on moving on accelerating New South Wales towards net zero. And part of what my team proposed was to focus more on the transport sector, as it is a really high emitter, as well as other things. So part of that analysis, we've identified that the heavy industry is one of the most hard to abate sectors. So that was something in my head at the time. And so late 2022, there was an opportunity for piece of research in this field offered by Ellie. So I jumped onto that opportunity. I sent some emails, and that was my first taste of academic tertiary research. I was a TASER research scholar, so a research assistant looking at decarbonising heavy vehicles. So I did that for around 6 months, and I returned to her early last year, early 2025, as a research honours student and this is where I'm going to present my research. So where my research is focusing on decarbonising freight, I'm sure you all know, in particular developing a system dynamics model to shift freight from road to rail. So I'm sure all you guys know Ellie's research specialty is in freight and decarbonising freight in particular. So she has some students on electrifying the rail freight network, and so this is my part of the jigsaw puzzle that fits into her, I guess, wider ecosystem. And I know Anissa's on the call right now, so she's focusing on developing an SD model to shift trucks from diesel to hydrogen or electric. So this is my contribution, and this is my piece in the puzzle, as I like to think about it. So I graduate, as Ellie said, I graduated at the end of last year. I had my graduation ceremony a few days ago, last Tuesday. And right now, professionally, I'm working at TK Riley in the project advisory team, helping to plan and deliver complex infrastructure projects for government clients. So the one I'm on right now, I'm on a road project. But yeah, so that's a bit of my experiences within UNSW. Outside of UNSW, I've also had experiences at a design consultancy, Santec, as well as E3 Advisory, who's a competitor to where I am right now. So, so happy for you guys to ask about questions on that front as well. But my main focus for today is what I've done throughout my academic time at University of New South Wales, and hopefully a lot of you guys are master students, PhD students, so it will probably give you a background on some of the research that I've done and that has been done for you guys to be motivated in your research journey and your time at UNSW. I guess what I'll save questions for the end, noting of time, and it's 1:16. So I'll save questions for the end, but I'll jump straight into it. So giving an introduction of the of my research. So basically, this is not going to be 10 minutes, Ellie. It's going to be probably like 20, 30 minutes. I'm just going to talk on the side as well. So it's not too condensed. So basically, when you do research, for me, how I view, especially in consulting, is that you don't jump straight to the solution. You really need to define the problem at hand, because that's part of research. Like for me at least, for me, I just don't see you can do research for fun, but for me, I strongly believe in making a positive difference to society, and I think it's important to understand what problem you want to solve before conducting your research. You can be very broad, but at least have a think about what problem you want to solve. So in this case, the overarching problem is climate change. As we all know, climate change is an existential threat to society, with every degree of warming contributing towards irreversible change to not only ecosystems, but to the wider economy. And part of climate change is looking at emissions. Emissions is the biggest source of climate change. So what we found is through data by the Department of Climate Change, Energy and Water, is that transport emissions are flatlining. So transport as a whole, which includes passenger vehicles, railways, heavy vehicles, commercial vehicles, buses, and the whole lot. So as you can see here on the right-hand side, the graph, you can see that as of 2024 projections, you can see that they are flatlining. In particular, whilst there is significant movement in freight, in passenger electrification, as well as decarbonising the electricity grid, freight emissions remain stubbornly high. And that's primarily because there is a high reliance on trucks, which is powered by fossil fuels, and there is really a lack of action to reduce emissions and transition towards zero emission technologies. Now we can dive into a bit further, but that's something to have in mind. So there are many different decarbonisation pathways. You can transition vehicles to zero emissions, such as transitioning trucks to from diesel to electric, or you can also shift freight from road to rail. So as during the time when I was doing my research, the opportunity to transition vehicles to zero emissions, that's at its infancy stage. I think right now it's still at its infancy stage. However, with the geopolitical events, I'm sure that will accelerate soon. But so there is an opportunity to decarbonize these vehicles using clean energy. However, there are challenges to that, such as these vehicles have a high initial upfront cost. You have to transition a magnitude of 750,000 trucks, which is quite a lot. A lot of these trucks have a long lifespan, 10 to 15 years. So as a result, what was identified is that freight can be shifted from road to rail, and that is a quick win. Rail emits 3 to 5 times less CO2 compared to road transport. And as you can see on the right, I think a key focus for the research is non-bulk freight. So non-bulk freight refers to the freight that is primarily in containers. They're not delivered. They're not like bulk freight would be your coal or your grain freight that is not containered, like that's straight into the trailer. So these freight usually accounts for the like your goods and services, your products that you buy from the shops. And the reason why we focus on this is that because bulk freight is primarily transported by rail. So there's not much opportunity for that. So that's the motivation. Now, just before I move to the next slide, and I think I'll talk about system dynamics in particular, I think it's important, but at the start, at the start of any research, I think it's important to understand the context of what's happening. And you need to, for me, and I was pretty bad at it when I was an undergrad, but I think you just have to be targeted at the research because there's so much information online. So you just have to be targeted in, I guess, what you want to find out from your literature review or what you want to find out from industry, because you can go into a rabbit hole. You don't have much time. I didn't have much time. So that's something to consider. And it's also important to know, I guess, once you develop models, develop your methodology, research methodology, and you test it, so you understand what's happening. So this is a one-page summary of the wider context of what's happening and the whole premise of the research. So if you move on to the next slide, if I can go to the next slide. So so once I've identified in shifting freight from road to rail, there are challenges. So there is a declining non-bulk mode share for rail. And historically, this non-bulk freight growth over the recent decade has been absorbed by road. So there hasn't been any new volumes for rail freight. Non-bulk rail freight has remained stubbornly stable. And mode shifts does require change of behaviour. There is a tendency for freight forwarders to prioritise road based on empirical surveys and workshops that was conducted in 2024. And so these were some of the things that were identified. Our city did a design thinking workshop, and those are some of the insights that we found. And lastly, I think we also need to understand that rail freight doesn't fully decarbonise freight transport without transitioning all vehicles to electric. So noting that shippers make decisions in a complex dynamic environment, with many different conflicting priorities, strategic policies from the government imposed on shippers can influence mode choice. So like policies on cost, on flexibility, availability, etc., can influence mode choice. So as a result of this, noting this context, system dynamics modeling is a good model to simulate the impact of multiple policies. Now, I'm happy to give you a quick introduction to system dynamics. It's been a while, so Hussein, sorry if I get this wrong, but system dynamics. The good thing about system dynamics is a model where if you define, I guess, a system which is within the circle, right? The good thing about system dynamics is that it can model the different implications of different subsystems all at once. So what this means is that, say that you have one factor, right? One thing, right? You can model the combination of one factor with another factor. And you can model this through reinforcing loops and balancing loops, where reinforcing loops is, say you have something, right, and it's favorable. As a result, more people will buy that more favorable thing, right? So that reinforces it, that gives more demand. Or a balancing loop is you have a capacity constraint. So the more demand you have, the less ability for the supplier to supply the product. So these things can be modeled within system dynamics, it can simulate the dynamic interplay of a combination of variables and policies, which as a result, if you simulate that into the future, it can provide deep insights of the key factors influencing the mode choice, mode share, and for my research, and it can help decision makers set targeted policy interventions, knowing that you have a model to simulate potential future results. Yes, there are limitations to models, but that's with every model. But that with models, the whole premise of a model is that it's not perfect, but it gives an indication of what's happening in the future. So hopefully that's a summary. It's okay summary. So yeah. So within the literature review, this is the summary of the literature review. In a nutshell, there's not many papers on system dynamics within Australia, in particular on shifting freight from road to rail. Globally, there's not much of that. And there's only, at the time of research, there was only 5 Australian papers within the transport sector using system dynamics, a few of which have been co-authored by you, Ellie, and Hussein. But yeah, what the key finding is that this is a research gap. There's no current literature in Australia simulating the impact of policies to shift freight from road to rail. So with research, you've identified the problem, you know the problem context, and you know that nothing's been done to it. That's the whole purpose of a literature review, is to verify whether anything's been done to it and to identify the research gap, which is that there's no current literature in Australia simulating the impact of policies to shift freight from road to rail. That's within academia. There could be some items within industry, but that's the focus of my literature review. As a result, from the literature review, the aim of this research is to simulate the impact of policies to shift freight from road to rail. That came from the literature review, which led to the research questions that I wanted to answer. So what are the key factors influencing freight mode choice? Are they able to be modelled? Which policies will have the greatest fuel and emission savings by shifting freight from road to rail? And which jurisdictions will have the greatest fuel and emission savings from shifting freight from road to rail? So these are things that were developed. And it's, I think, for me as a student, at the time with not much experience in research, I think it did change over time as I start to understand the topic a lot more. But I think the second thing is that the second question definitely came from a lot of the front end research, which was identifying the context, knowing that the government is a key decision maker and they can make big changes. I think that's a key, and noting that I think that's a key thing to address, because they can implement what policy, X or Y policy, and they'll have a big impact. So I think that's something to consider in your research, is whether it's practical. So my research contribution is developing a policy assessment tool using system dynamics to shift freight from road to rail. It simulates mode share, fuel use and emissions for 13 subsystems, which I'll explain later. Incorporates 4 policy mechanisms that can be applied independently or in combination. That's the beauty of system dynamics, is that you can choose which items to simulate or not. And as a result from this, from the data, from the simulation, I extracted subsystem-specific insights to determine which jurisdictions to prioritize for policy implementation. So basically, which subsystems, which areas, geographical areas, and which had the distance traveled intrastate, interstate, which areas to focus on for policy implementation, noting that what's being provided is the emission savings, the fuel savings. So, yep, as I mentioned, each subsystem corresponds to jurisdiction. So whether the New South Wales, Victoria, state or territory, and distance travelled, whether they travel interstate or intrastate. So interstate is between the states, or intrastate is within the state. So this is my research methodology. I'll just go through step 1 to step 6. The first thing with system dynamics is that you need to define and I think with modeling in general, is define the assumptions that you're going to make and define what you're going to model and what you're not going to model. In this case, it's the system boundary. So what this means for me is I collected and collated current and historical data. A key challenge with that is that there was limited data, so there were assumptions that I made. And secondly is from this, you need to understand what is available, which does take some time and it is tedious. But once you know what you can do, where to focus your efforts on, whether it's, I guess, bulk or non-bulk freight, then you can develop the system, your model. So you can define each subsystem specifically for system dynamics, define the model components, and identify any relationships and causal loops. Now, I'm not sure, Hossein, this is not best practice, but I spent a lot of my time, I think a solid 7-8 months, just defining the system boundary. And I think for me, I rushed through the model only maybe 1 or 2 months. So it goes back to my first point, is that you need to be targeted in what you want to focus on. Yes, you have to be exhaustive in your literature reviews and all that, but you just need to really try to be efficient. And I think I learned the hard way, but you all experience that as you all learn and grow within your academic journey. So you develop the system dynamics model, which includes defining each subsystem. So what is each subsystem, defining the model components, so what the model contains, and identifying any relationships and causal loops. Then I calibrated the model. So the thing with system dynamics is that, or any model in general, is that you need to ensure that what's being and I'll explain to this later, I have slides on it, is what anything you simulate in the future needs to correspond to what's happened in the past. So I calibrated the model so it closely tries in best I can to closely match the historical data. There are some limitations to that. From there, I then introduced some policy interventions that include internalizing externality costs for road and rail, road access charges, road expenditure costs, and fuel tax credits. I can explain, it could be a slide later on for that. After that, I simulated the model. So I ran the model between the financial years 2023 to 2024 to 2049 to 2050 with a time step of 1. And it's just playing around with the model and the simulation and seeing which interventions have the most impact. So I looked at mode share, fuel use, emissions, observable costs, and subsidy viability. And lastly, I extracted the model insight. So that's part of number 5 as well. As when you play around with the model, simulate future years, you extract the model insights, which from the data. So which areas have the greatest emissions, savings, fuel emissions, and for my research, they're all closely linked because fuel use does have a corresponding impact on emissions. So, and from there, you can focus on your recommendations moving forward. Next slide. So these are the subsystems that correspond to each state and whether the non-bulk freight will travel interstate or intrastate. Noting that I didn't have any for ACT because there was a lack of data. Tasmania interstate because it's an island. All the historical data corresponding to interstate is mainly on a boat because you need to use a boat. Shipping. So that it's just, so I think when you calibrate, back to the previous slide, when you calibrate the model, you need to understand the system boundary. Well, when you do for system dynamics or anything for any modeling, when you do your step 1, just defining your assumptions, you need to understand the modeling process such that you need you like when you model something, you need to base on an assumption. If you don't have that assumption available, that can't be modeled. So that's why Tasmania interstate's not there. So let's get into the nitty-gritty of things. So in the model, right, the thing with the model is that with the mode share, and this is based off what's been accepted, what's been universally accepted, is that the percentage of those that travels on a particular mode within transport is based on what is it called again? It was called the utility function. I can't remember what it's specifically called, but regardless, you can. I forgot. It's in my paper somewhere. I forgot what it's called. It's not in here, but it's based on
Logic
this
model.
formula. Logic model. Yes, it's the logic model. Thanks for reminding me. So it's the logic model. So the logic model is where the mode share of whatever is dependent on the utility. And that utility is defined by these corresponding formulas. So usually it's a sum of all the beta is the, the coefficient of utility. And then you multiply that by the cost value or whichever quantitative value. Now, in our case, we've separated this into cost and non-cost, where cost information is readily available and can be defined. However, the non-cost attributes, which usually is your service quality factors such as time, reliability, flexibility, accessibility of the freight, of the rail and road freight network, that hasn't been adequately defined. So as a result, that's just an error that we're going to put at the back. So these are the formulas, and these are the formulas that we're going to use. Okay. I'm not going to explain too much about this. So you have, this is in one of the subsystems of one of the subsystems. Right? Yeah. So for example, this could be New South Wales intrastate. So you get all these costs, right? As I said, I separate that into cost and non-cost. So for road utility, there's a road cost component and there's a non-road cost component, and there's a rail cost component and there's a non-rail cost component in here. So that's this that's one of the subsystems, and that corresponds to, in the model, this part in the left-hand side in the red box. Yeah, freight task as well. So which is based on a stock and flow diagram. That's been derived with that's been calibrated using historical data. And you also have rail costs, which in this case, there are some feedback loops. There's some, so for those who are not familiar with system dynamics, any R relates to a reinforcing loop, which is if you, for my case, if you decrease the cost of something, you increase the attractiveness of something, which will induce an economies of scale, because you increase your demand, which will further reduce the cost. So there's that for rail. There's also one for rail subsidy as well. So these are the loops that I have. So I have the main loop, reinforcing loop, is with economies of scale, where for rail, where an increase in rail freight will result in reduced costs, because each rail can, you just put more trailers on. You're not increasing the crew costs, you're just increasing the size of the train. Same with the locomotives, same with repair and maintenance, and same with track access charges. Obviously, these are based off assumptions, but you have to make those assumptions when you do any type of modelling. You also have a rail subsidy as well. So that's a key policy intervention. So it's reinforcing loops. So in the rail subsidies space, revenues will increase from rail externality costs. So when where there's externality costs being induced on road and rail, when there's for rail in particular, when there's increased rail freight tasks, will increase the revenues collected by the rail externality costs. It's not the best one, but it's just there. It's just captured to be exhaustive. I think that's important in system dynamics, is that try your best to incorporate as many feedback loops as you possibly can think, because that better captures what happens in reality and justify them as well. However, when you increase the rail subsidy, you increase the amount of rail being carried, right? However, there's only a limited amount of rail subsidy to go around with more rail freight. So when there's more rail freight, you have less subsidies to share per ton kilometre, which will reduce the attractiveness of rail. So they'll go back to road. Some rail freight will go back to road. So that's a balancing loop. So when there's something positive happen, it balances back, goes back into its normal because there's some effects that's happening. And additionally, when there's an externality cost put on road freight, when there's an externality cost on road freight, what this means is that if that externality cost on road freight is subsidizing your rail such that rail is more attractive, your road freight, some of it will move toward rail freight, and as a result, there's less revenues that your externality cost will be like that the government collects. So as a result, let me just, you can see here, I think it's better if I explain it here. So if you can see on the right-hand side, I can't zoom in, unfortunately, but if you look at rail freight, see if I can write on my thingy. So if you have a look at your, rail freight, right?
Yeah, that's all right, Matthew, because
So
everyone actually has the link to the web-based tool, so they can open it on their laptop and then they can see it. So maybe you can go on to the next one.
But as long as you understand what a balancing loop is and a reinforcing loop, then I'm happy. But what I'm saying is that when you increase one thing, right? For example, if you increase the freight carried per train, that would increase your economies of scale, that would reduce your cost, as you can see by the plus, minus. When you reduce your cost, you reduce your rail cost, which will increase your utility, which will increase your rail mode share. And once you increase your rail mode share, you'll increase your rail freight, which will further reduce the cost. So I try to explain the best I can. So that's a reinforcing loop, and a balancing loop is where if you increase something, right, there's a negative effect. For example, if you decrease your road mode share for road, right, that would reduce the revenue collected, which will reduce the rail subsidy, right, which will increase your cost, right, which as a result increase your rail cost, which would make more people choose road. So you can have a look at that in your own time, please. Have a read of it and try to understand what's happening. So there's 4 policies. I'm running over time. There's 4 policies: internalizing externality costs, road access charge, road expenditure costs, fuel tax credits. These were based off expert advice from not only Ellie. This is from Ellie. These are some of the things I also wanted to test as well. And what I'm saying is that for research, I highly encourage all you guys to be industry focused, be realistic, and understand what can influence decisions, and understand what solutions are there. For example, like with tax and all that, these are some of the taxes that exist. That what happens if we can remove a fuel tax credit. That's what exists right now. So just try to be realistic and grounded to reality is my best advice. That's where a lot of your front-end work needs to be done as well. And these are some of the results. There's a policy dashboard as well. When as part of my front end work, these are the what I have for the road charge, which is equivalent to $1 0.36 to $1.72 a litre extra charges for internalized externality costs for road. That's with rail, because rail is diesel powered. Road access charge that can be set by the policymaker. Road expenditure charge, I derived that from BITRA. So what that means is that the current fuel excise cannot fully fund maintenance. So this is the extra charge, so it fully funds it. And if you remove fuel tax credits, this is the charge. Now, I made up those. Policy 2, policy 3 is from my own. Policy 4, the reason why I got policy 4 is I saw an AFR article on the climate change chair, Matt Kean, on suggesting we should remove that. So I wasn't originally putting that in, but I think it's part of research as events, you need to be flexible. So that's something to consider. Results in this policy dashboard, you can have a look at that. I'm sure you have access to it. The summary are as follows. And if you want to play around with the dashboard, which honestly will be like, the results may change because the calibration is being rejigged. But I expect the results to be around the same. Internalizing externality costs and removing fuel tax credits will have the most impact with these following results. And applying multiple policies in tandem will result in marginal gains as rail operational costs are already low. Now, if you have a play around with this dashboard, what you'll find out is that there's a section for cost, so you'll find out that costs will go to zero, right, for rail because they're already being heavily subsidized. So I had a limit for the model where the model does not go to that any zero, like the government will not pay freight operators to use rail. It will only be such that the subsidy will only cover for the costs, and that basically the maximum subsidy is where it fully subsidizes the operational costs. So if you externalize externality costs up to 1.1 megaton per annum carbon reduction, if you remove fuel tax credits alone, it's 0.6. New South Wales and Queensland will see the greatest fuel and emissions reductions. I think that's where it's important to differentiate different different states. That's where policymakers can really focus their efforts on. And subsystems exist are still heavily reliant on road freight that are not sensitive to cost. So as per the calibration, there are some areas where they are still highly dependent on road freight, which is a key concern. And those areas have been identified. So the recommendations are to, 1, consider removing fuel tax credits instead of internalizing externalities. So the results summary should be objective. It should be based on the results. It must be based on the results, right, of your experiment or your model. Where your recommendations come in is your analysis into why, and considering your external factors, considering what the government can do, what they can't do. This is where the recommendations come in, based on my own critical thinking judgment. So the first recommendation is to remove fuel tax credits instead of internalizing externalities. The reason why is that removing fuel tax credits is generally easier to implement and will not be a cost burden to road shippers, while you can still deliver substantial savings in emissions, so 0.6 compared to 1.1. It's still a big difference, right? But it's still quite a lot of emissions. And the idea of the government implementing a tax is not that, it's depending on their political agenda. There's some political sensitivities around that. So that's based on my judgment. That's where the recommendations come in. 2, and this is straight from the data, is that New South Wales and Queensland should be priority for policy implementation. 3, ensure rail cost remains low over time. That's because once there's an increase in rail costs, people will move back, the freight will move back to road. 4, these areas should are the areas where they are not reliant on cost, where road freight is still dominant, right? And this includes New South Wales intrastate, New South Wales interstate, Queensland intrastate. These areas. And 5, policies must be paired with zero emissions technologies in the future. Even though all the freight is moved from road to rail, because rail is diesel, is still a fossil fuel, there needs to be future research into that. Already it's happening with Sophia Shibe and Gia, so you can talk to those people about that. That's more on a technical front, more on a technical and commercial front, and while Miles more strategic. What else is there? So as a result, this is a summary of my research. Some limitations, some data sets are incomplete. Conclusions are so there are some assumptions that are made in the first stages because there is a lack of data available. Secondly, and this is with all the modelling, is that conclusions are generalised and cannot be attributed to a specific cause. Now, this is where correlation and causation, a lot of people get mixed up on this. If a data shows a particular pattern, that's correlation. However, causation is where you have this data and you can attribute that to a specific cause and you know why. So correlation doesn't mean causation correlation can mean causation if you can justify the reason why. And a way of justifying it is through empirical observations, talking to industry, understanding why freight forwarders do all these items. That's for another subject, but a key thing with modelling is that, and which I know it's not in the slide deck, but I'll go over the process of calibration, is that even like I said that in previously, these are the areas where I think there may be an issue with non-cost service quality. That needs to be proven, right, by on-the-ground research. That hasn't been done in my research. So I think maybe I could have said, look at these areas and figure out why that's the case. That's for a future research topic. Route specific factors are not considered. So is there constraints to, I guess, a particular route, right? This is all done high level. And the model can't simulate non-cost factors because there's not much historical data. So that's the end of this thing. Just before I go to questions, I just want to quickly go over the the calibration process. So in a nutshell, what I've calibrated, when you the third step is calibration, and it basically is matching the data between, try to match as best as I can the data from 2013 to 2014 to 2023 to 2024. When you try to do that, right, I don't have this thing open, but if you can have it, it's in the the dashboard that I made. The main things that I calibrated is so I calibrated the coefficient. So I calibrated this, and I also calibrated this beta and this beta, and I also calibrated these error values as well. So those were based off historical data, and the way of there's paid models that you can use using VentSim, and it does the calibration for you. But the student model, you have to calibrate that. You just have to do trial and error. So these beta values, these error values, those were derived. Just playing around with them, it is a bit of a tedious process, but that's how calibration works. And I guess as a result, depending on the calibration, that does have an implication on number 4 and on number 3 for results and number 4. But I anticipate, because it's based on historical data, I don't think there's going to be much of a difference. But that is something to consider when doing modeling, is that your model is only as good as your assumptions. So yeah, but the main thing is don't get held back by this, by the fact that, oh, it's not 100% perfect, because models aren't not 100% perfect. At least you're doing something instead of just sitting around and doing nothing. At least you're doing something. At least you can have something that you can present to a government. Yes, don't say this to government. Yes, it's not 100% perfect, but nothing's 100% perfect in models. This is what we found, and hopefully, like, you can get the government starting to talk about, oh, maybe we should try this because it may have emission savings, and it could lead to further interventions by government and recommendations by the Department of Climate Change to the government for them to make. So it could be a start to something, and it doesn't have to be perfect. There's a rule out there: 80%. You do 20% of effort to get 80% of the work, or something like that. Don't strive for perfection, but strive for excellence. So don't try to get yourself bogged down in the fact, oh, it's not it's good to be accurate and to be diligent in this, but just try and just focus on your the bigger things in life in that sense. So I'm happy to stay behind. I know it's 1:58 now. I'm happy to stay behind for 15 minutes more. I know I'm a bit over. If you have any questions, I can discuss more about my research. Yeah.
Great. Thanks.